Everybody, thanks for coming and watching the Lakeshore Fab Lab episode 3 Tech Talk. My name is Chris Kaminsky, and I'll be one of your hosts today. And I run the Lakeshore Fab Lab in downtown Muskegon, which is a community makerspace. Think YMCA plus gym, or think a gym membership like the YMCA plus like a shop class from back in the day. So we have tools and resources to help all sorts of folk. Like today, we have a First Robotics team that's going to be on the episode, and they have quite a shop set up at their facility as well. But we have some resources that are helpful to them and everybody else. So with me today, I have Mike 1 and Mike 2, and also a couple students who you're going to meet, and they're going to share some experiences and show you some cool stuff. So with that, I'll let you take it over.
As Mike 1 on the team, Mike 1 only because there are a number of Mikes on our team. So we started numbering ourselves. My background is in electrical and computer engineering, and I own a small business here in town, and we actually run the program out of my shop. M.A.R.S started in 2012. Muskegon area robotics students got incorporated, and we're now a nonprofit organization. And our goal is primarily to get students of all ages involved in STEM. So we're trying to either help them discover STEM talents that they may not know they have, or improve their interests. If they already are into that kind of stuff, we have all kinds of things that they can play with and improve their skills. And these are all real world skills. A lot of companies in town have indicated that they're looking for more of these skills in students that sadly they don't teach in schools anymore, with most of the shop classes being gone. So we kind of fill that void a little bit. And we do this by participating in a program called First Robotics. And First Robotics builds robots. And they borrowed from the book of sports, the playbook of sports, where you get people excited by having competitions, right? And so every year there's a new theme that they unveil, and then the kids go away and they build robots and go to competitions. And they're pretty exciting. We actually had our first competition here in Muskegon last year, and that went over really well. Unfortunately, this year it got canceled just as we're about to set up. All the schools got shut down, so that was a bit of a bummer. Kids built a robot. Many teams in the area built robots and couldn't even compete yet. But we're hoping to catch up and have a great time with that next year.
And it was a really cool theme too, right? Like Star Wars. Come on now, people.
Oh, I know.
It's like what every nerd's waited their entire life for.
Oh, I know. We were all so bummed. But from what we heard, they're going to replay the game next year, maybe with a few little tweaks here and there. So not all is lost. It's still going to be the Star Wars theme next year, and we can all dress up as our favorite Star Wars character and do all that cool stuff.
Jar Jar.
Yep. So stay tuned for next March when the Muskegon competition is back on, hopefully at Orchard View, and I hope to see a lot of you out there. So that's kind of a bit of how M.A.R.S got started.
Awesome. Yeah, and I was super sad because I'm like, oh my gosh, it's Star Wars, and I have a guy that has a working R2-D2 that can go to the competition. So
I've been in touch with him, and he was supposed to be there with it, so that would have been super cool to have that drive on the field with the other robots at one point, and do a little cameo for sure.
Pit R2 against the other robots.
Right.
Oh man.
Sweet, man.
Yeah. So we do have 3 of our students with us here tonight, and after Mike says a few words, we'll put them on, and they'll kind of talk about what they do on the team. But I think that's probably all I want to say, because I think we really want to hear from the students more so than us.
For sure. Folk. Us old folk, exactly. All right, Mike 2, you're up.
Yeah, 10-4. Well, so my name's Mike Reynolds, otherwise known as Mike 2 in the world of M.A.R.S. I'm a engineering technician for a company called Effective, which is a part of Comcast. It's their advertising division, if you will. I've been doing that for 22 years. Lots of IT type work. When we call it engineering technician, it's more of a hooking it up and making it work, putting technologies together to make solutions, as opposed to designing the solutions from the ground up. So maybe a technologist maybe is a better description. I'll have to talk to HR about that. Before that, I was a bench tech at Brunswick. I went to MCC and have a associate's degree in electronics technologies, which was enough to put me on a bench repairing automatic scoring equipment at Brunswick for 5 years. And then I got bored and moved on. I'm a hobbyist. That's how I fit into all of this robotics. I was attracted to robotics, eating dinner with my family at Wendy's restaurant, and the Reese Puffer team was fundraising and recruiting. While I didn't even know it, they were trying to take care of my tray, and I said, "What are you doing?" They said, "Well, we're this robotics team, and we're fundraising here at Wendy's." And I said, "Well, you're going to have to tell me about your robotics stuff." And that was the beginning of being introduced to FIRST. Sure. And 10 years later, almost 11, I'm still doing it and digging it. It's total fun for all to be able to get kids excited and interested in building things. The whole maker concept. A lot of kids don't even realize they can do that stuff until you put them in front of the equipment and give them the tools, and then it sticks. And you'll see that here as our kids talk about what they're doing on the team and what they're going to do in life as they move on. Really cool stuff. So fun facts: 3D printing, beer brewing, microcomputer projects. I love the Arduinos and the ESP8266s, the Raspberry Pis, all fun stuff. Making things move with technology is what I like to do, including displays. So I like music, play guitar. I'm a arcade machine nut. I love pinball, video games, slot machines, jukeboxes. I have a claw machine that I'm refurbishing. All that kind of stuff keeps me going, and between the tools that I have available at Robots and the Fab Lab, it really keeps me going.
I feel like we need a claw machine as you walk into the Fab Lab. It's just like,
all right, let's make one. I love it. I'm very resourceful. Look out.
sure.
So Mike and I started M.A.R.S together. We were both recruited in different ways by the Reese Puffer FRC team, and we went for 2 years, and we couldn't believe what we saw, and then the Reese Puffer team kind of dissolved themselves, and it didn't take long. Mike and I said, no, we're going to do this ourselves, and let's do it in a community fashion, which really fills a hole in, not all the schools in the area have a program. So right away we were able to draw from some of the smaller schools, offer a venue for homeschool kids, and put together this program, which has really taken off. It's been very successful. Tireless work, but it's worth it in the end. Yeah, for sure. So we do the high school stuff, the FRC, and we brought those kids here to talk today. But I noticed my good friend Micah is sitting down there, and he's been with us for a couple of years on what was our middle school team, and he's ready to go to the high school team now, which is exciting. You bet. So yeah, we've reached out to a lot of people over the years. The middle school team has now changed a little bit. We used to work within the walls of FIRST Robotics in the middle school venue, and since then decided that we would like to try and change that a little bit and take the competition level out of it and try and build some groundwork for the kids, kind of a base, give them give them that base to build from, so that when they get in front of the big robot, they've already got some wherewithal and they're ready to go and be active in the building. And we weren't getting enough opportunity to do that, I don't think, with some of the younger kids in the fast-paced first program that was the FTC. So we picked up the VEX kits, and anybody down at the Fab Lab has probably seen these VEX kits down there. There's a table that it's played on, and you've got the robot that you program with a lot of software. It kind of looks like Scratch blocks, they call it. And it's a great way, we found, to teach some basic mechanical design. Easy to put together pieces, but most of them are made so that they can do all the simple principles of the machine basics, and then we program them to do tasks. We usually buy the field kit that the VEX Robotics Challenge uses. We don't compete, but we play the game with the kits that we have with the kids, and that's been turning out pretty well. So we're pretty excited about that too. That program's called M.A.R.S Mission Prep, trying to play into the whole M.A.R.S theme. We're preparing the kids for their missions, and their missions are going to be in the FRC world.
That's awesome.
And we've also got the FLL team that runs with us, and they're doing the Lego stuff. The first Lego League is what FLL stands for. So within our organization, we have at least 2 of the 3 first programs, and we'll see where we go with the middle school program. We could end up back in the first community in their FTC stuff, but it's been fun.
It's good to always be evolving, right? Trying new things. And
absolutely.
You guys are doing it with your program, so that's good.
Yep. You never know what's gonna work best, so you got to keep trying things, because the next greatest thing might be around the corner.
Right.
So we got 8 to 10 kids, 6th to 8th grade in the middle school program, and Micah can tell you, we have a lot of fun, and kids get a lot of chance to explore, learn mechanical designs, just basics, learn the programming basics, and they also get a chance to learn some of the core first fundamentals or ideals, 2 of which are the gracious professionalism. They like to teach kids that in even a professional capacity, it's okay to help others, and it goes along with the cooperation concept, and that's the kind of concept that we can work together to make us both stronger and have even more competition. Everybody raises the bar collectively, so that kind of stuff is really cool that that stuff came around, and they're great.
That's kind of like related to everything going on right now with Corona stuff, right? Like it's
absolutely
you guys are making PPE. Like I'm in groups making PPE. Like we're all just like you guys were some of the people I reached out to, and like all of a sudden I need a laser. I'm like, guys, I need a laser. Boom, right? And like these different industries are cooperating. They might be competitors previously, but now they're all working together. So
yeah, you bet.
Teaches those concepts. It's awesome.
It is. It's great for the greater good. And they all get a chance to learn some hands-on collaboration with other team members, as we're going through all that stuff, and the whole team building stuff is really great for kids to learn. The earlier they learn it, the better. So that's pretty much what I got. And now these kids are gonna knock your socks off. Who wants to go first? Matt?
I'll go first.
All right, if you want to spotlight his video, Holly.
Where did Matt go? All right. There we go.
Need the elevator waiting music.
Yeah. do 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 do. Okay.
Right.
Hi. I'm Matt Reynolds. I am an 11th grader, and I've been on a first team since I was in the 3rd grade. It started on the Reese Puffer teams, and then as they dissolved, I moved into M.A.R.S. What I do is I am the CAD/mechanical lead for the team. That was new this year. The past year, I was kind of the second lead for the team. I worked alongside Nick to make the things happen that did. And what I'm going to talk today about is the importance and how easy it is to use CNC machines to manufacture parts that would take a while doing by hand. So I'm going to share my screens here. And so here's an example of a part which I also have in my hand. It's got a bearing in it in reality, but it's a fairly simple piece just because I didn't have a whole lot of time to make something complicated. But what this is for is it is a cover plate for a gearbox that we are making for a part on our robot that needs to have one motor driving two belts that need to spin opposite of each other. So instead of, you know, getting a piece of plate and marking it up and cutting it out and drilling all these holes in by hand, what we can do is we can draw it up in CAD, and then simply using SolidCAM, we can create toolpaths in G-code, which can be applied through the post processor to any CNC machine, whether it's a router or the Haas at the Fab Lab or the shop bot at the Fab Lab, etc. The way usually that you'll start it is you'll create a part, and then with trial and error, of course, you'll learn how this works a lot better than I can probably explain it, because that's probably the best teacher is failure, as long as you keep working off of it. And we've had plenty of that. I actually broke a bit today trying to make this piece because it's been so long since I yeah, sorry, it's been so long since I touched it. But you know, then again, I learned a lot of things and I probably won't forget them now. But you'll start with a part.
Sure.
And then if you're using SolidCAM, then it's fairly simple. All you have to do is define your machine, which I don't have the Omeo in here, but if you
That's just
when you
right
do get a
inside
machine-
SolidWorks, right?
Yep, this is right inside SolidWorks, and so it's really simple to use with SolidWorks. Then it's no outside plugin or anything. It's all just built right in. And you guys have SolidWorks licenses at the Fab Lab, right? I'm not mistaken.
Yep. Okay,
so this all should be there as well. So yeah, you make a part, you define your machine, you set up a coordinate system. Mine's up here. And so on the cut bed, the X's and Y's will all line up, and then it's in the top corner there. Only because that's a place to then line up. If you have a piece of stock, it's easy to line up on the corner of your part than, let's say, estimate where the center is. So you can create your origin, and then all you do is click extract machinable features. And what that will do is it will go through and it'll find all your cuts and your extrudes, and it will make a list of parts, a list of machinable features in this tree here. So I have my different hole groups and then my exterior boss, which will be the final path that cuts everything out. So then after you do that, you go through and you create your machine operations, like your center drills or your rough mills or whatever you want to do. And then after you have that, you click generate toolpath, and it creates all the toolpaths for you. And you can preview them and make sure they're all good in there. And then all you have to do from there is click post process. And then you pick a place to export it, click save,
Boom.
and then press the play button. Yep. And it writes it all for you. Right there's all the G code you need. And it's that simple. Then all you have to do is bring it to the machine, whatever you're using, and then upload it and then run it.
Does it now if you're doing a profile cut like that, are you cutting out of like a bigger stock and having tabs and all that stuff, or?
Yeah, you can have tabs.
Sure.
Really, the best way to anchor it down is up to you. I mean, we tried to do tabs, but then it became a little complicated. So what we started doing instead is putting extra holes and then just screwing it down into the wasteboard.
Makes sense.
Yep. And so, like I said, trial and error is going to be the biggest part. We spent months before we even got the simplest things to be cut out on this router, learning and playing. And we've documented all of our speeds and feeds in a spreadsheet such as this for all of our different materials, and whether we use coolant or not, and then the RPMs of the motor and the feed rate and the depths of cut and all that. So it really just takes some time, but creating it and getting started with the trial and error process is not that difficult at all. And I recommend everybody that has access to this stuff, go play around with it, because it's a blast once you start making things.
It is. It's cool being
Because
able to take that computer.
to have something that you made on your monitor come out just like it looks,
Yeah.
it's
Yeah,
definitely an experience.
Bring that closer to the screen. So you can see there's that bearing pressed into the center there.
Yeah, I would take it out, but it's super in there.
Pressed in there, yeah.
Yep.
Oh, were you showing on your video? Oh,
Yeah.
Oh, yeah.
Sorry.
So, yeah, zoom, or yes, there you go.
I can do that. So this is exactly what was on the screen, I guess, with the addition of a bearing.
Sure.
But to have something like that come right off your screen into your hands is definitely an experience.
Like, I love 3D printing, but there's something about like machining that is so satisfying.
It is. And then in CAD, I know Nick's about to talk about that a little bit more, but you can get
Sure.
more in depth with your assemblies. And the part that I just showed you is actually going to go right on top of this bracket here that I've selected. And this is the back plate for the gearbox.
We don't
But
see your
this
screen
is-
again.
You have to
Oh,
share your
sorry.
screen, Matt.
Here we go. There it is. This plate here is the one I was talking about. That's the back plate for the gearbox. And the plate that I was just showing off is going to sit right on top of it
No, right on.
with the gears inside. So these are some of the assemblies that we can make, and Nick's got one that he's gonna go a little more in depth on. So I'm gonna let him do that.
All right. So, hi. Thanks, Matt. My name is Nick Gerstweiler. I am an alumni of this team as of 2019. I started in first when I was in fourth grade. And so, yeah, basically, I'm going to be demonstrating and showing how CAD can be so useful in large, complex assemblies. And to demonstrate this, I have one of our swerve modules here. So what a swerve module is it's a coaxial drive system, meaning that there are multiple axes rotating inside of each other. And this allows us to drive any direction on the field whenever we want, however we want. We can spin while driving in a straight line. And yeah, so basically how it works is you have your drive motor here, and this spins, that will turn the wheels. And then you also have your azimuth down here. That's this motor, and that will control the rotation of this saddle, which holds the wheels. And so here I will share my screen with our initial model. So there are two ways CAD sort of helps us on our team, and these are with the initial designs and the iterations. So for the initial design, this is an example of our initial swerve design. And CAD is great for these initial designs because some parts need to be precise. Like for example, this piece, the one with the azimuth rotation, those two pieces rotate inside of each other, so they need to have pretty small tolerances to work right. And with CAD, one of the nice things is you can just give a machine a part file, and like Matt talked about already, it'll give you the part almost perfectly with such a low tolerance. And so we actually had some of these parts made out of house by some of our sponsors because we're not able to get that precision, but with the sponsors that have the machines, we can get that just by sending them a CAD file. And now also CAD is just such a great visual that sorry. So you can see your parts ahead of time. And if something might be a potential problem later, like say you have two pieces that are intersecting each other, you'd be able to see that in CAD, whereas you wouldn't be able to just think of every time that might happen in real life. And so CAD offers, or it's very resource friendly, very time friendly, money friendly. You save a lot of time, resources and money, I guess, when you use it. And so that's sort of for initial design. And then with our, before we go over to Swerve 2.0 though, what I want to make sure, so this right here is an encoder. And for anyone that doesn't know, an encoder, it's just it reads the direction that a shaft is facing, I suppose. So we use it to read where the saddle is, so which direction our wheels are facing in each pod. And so that actually proved to be a very big issue with the encoder being where it was in 2018, because in our first competition, things went wrong and our robot never drove for the first competition, so that wasn't too fun. But this is where iteration comes in, and so we moved it to, it's kind of hard to see, but we moved it over to the other side of the belt. And the reason we did that is because these belts, or the belt that was on the azimuth that rotated the saddle, it kept jumping. And so we decided that, hey, if we can find a way to put this encoder on the other side, then it's going to read the saddle's position directly from the saddle. It's not going to have to go through a belt system. And so we were able to do that using CAD. And you can sort of see here, some of the tolerances and some of this stuff is you wouldn't be able to get it without using CAD. Like, it's just impossible. And so going off the iteration, this is sort of the difference between the first and second one. You can see first one's a lot bigger, and it's also a lot heavier. It was 5.1 pounds, whereas the 2.0, it was 3.1 pounds, making it one of the lightest in the world.
Wow.
And yeah, we really need to cut down on as much weight as possible, just because we have a 125-pound limit every year. And so just taking off weight anywhere we can, yeah.
Yeah, I mean, how many swerve drives do you have on the robot typically? I mean, are you thinking, is it?
We've got four per robot, just one on each corner.
Gotcha. Yeah, that's what I figured. But yeah, I mean, if you save 2 pounds a piece, that's 8 pounds. That's a pretty good chunk of change when it comes to 125 pounds.
Oh yeah, it all adds up very quickly too. And so with this iteration, here's just an example of the next thing we're working on. It's our Swerve 3.0.
Top secret.
Yep. And so, yeah, I mean, you can just see this stuff gets smaller and smaller and smaller, and that's because CAD helps you visualize this stuff, and you can see, okay, this might not work, or this will, and you don't have to go through all of the different prototypes that you may have made without CAD. And it just saves so much resources.
Now, have other teams reached out and asked you guys, like, hey, will you share the design with us?
Oh yeah, all the time. And that's honestly one of the best things about FIRST, is how open everyone is to sharing things. But yeah, so we shared I don't remember how many teams exactly. There was a few, at least 5, I'd say, maybe
Sure.
5 teams that have asked us directly, hey, can you share this? Like, we'd like to see it. And of course, like everyone in FIRST does, we posted it on GrabCAD, and Chief Delphi, we published all of our CAD files. And so, yeah, people could get it from there. And that's really how how it started, because we started this model in summer of 2017. And we got the basic idea from a team, Strike Force 2767, they're in Kalamazoo. They helped us out a lot. They sent us a picture. We had questions. They answered them. They helped us with the initial design. And yeah, it helped back. This is sort of where the cooperation helps, because we got this basic design idea from them. And then just this last year, when we moved that azimuth encoder over to the other side of the belt, they took that design and they were going to use it in their 2020 model, or they did use it in their 2020 robot. But yeah, with COVID, I don't know if you'd call it a season or not. I don't know.
Sure.
But yeah, so they gave to us and we gave back to them, and so everyone's just helping each other.
Open source. That's awesome.
Yep. And so yeah, I mean, there's this, and then there's also like Harrison's going to talk about all of the crazy programming stuff that goes into Swerve that I could never understand.
That's a pretty. I was gonna say that as you're explaining it. I'm like, my God, there's got to be like a crazy amount of complicated programming going into this thing.
Yeah.
Awesome. So are you going to be kind of involved with the M.A.R.S team, since like, you know, you're a veteran? Like, obviously if you're up in the UP at school, it'll be difficult, but as an advisor, mentor, like once you're part of first team, it seems like you never really actually leave.
Oh yeah, no, you don't. I mean, it's definitely hard being away. Like once it was build season and I was at college, it's like, wow, I should be building a robot right now, but I'm not.
Sure.
But yeah, I mean, I plan to help, even if it's just like a video call to talk about, hey, do you have any ideas for this? Or like, do you think this part might conflict with this part or something? Just to help, not like coming up with any designs or anything, but just helping.
Right. Cool. Yeah. All right, Harrison, my man, you are up.
All right. So, hello, I'm Harrison McIntyre. I'm in 11th grade. I'm homeschooled, and I've been in M.A.R.S for 8 years. So I joined back in the Lego League FLL, and I went up through the middle school program, and now I'm doing the high school level. So I'm the programming / electrical lead for M.A.R.S, and I'm going to walk you through how we take some of the assemblies and finished parts that Matt and Nick talked about and how we make them move and do the things they were intended to do. But so we're going to talk about the Swerve assembly mainly, and then we'll go over to some vision processing after that. So in 2017, when they finished the first prototype for the Swerve, you may think that they were like, okay, so this is really difficult. We're going to give the programming team a heads up. But then they were like, no, okay, so they finished the first prototype, and then build day, when we get the challenge, they were like, hey, so have you heard of Swerve Drive? And we were like, no. And they were like, you now have 6 weeks to program one of the most complicated drive systems on the planet. So that was definitely a learning experience with lots of failure, but we managed to get something to work. So Nick talked a little bit about how the Swerve works, how it operates. You've got 4 pods, 1 in each corner of the drive base. I'm going to share my screen here. I've got a diagram that depicts this. All right, so you've got 4 pods, 1 in each corner of your drive base, and they can each be rotated and driven independently of each other. So that lends itself to a lot of really great motion. If you think about it intuitively, you can just point all the pods in the same direction and drive them at the same speed, and you can just move around regardless of which way your robot's pointed. And for a comparison, if you think of how a traditional car works, if you're parallel parking and you're trying to get into a spot, you come at it the wrong direction, you have to back up and come at it from a different angle. Well, that doesn't really apply for Swerve, because you can just move in any direction you want at any time. And then you can also rotate from the center of your chassis by pointing all of the wheels at 45 degrees to each other. And so this is the main reason and the main challenge that makes Swerve such a worthwhile endeavor. So I'm going to open up a simulation here. So one of the other great things about Swerve, apart from the ability to move anywhere you want, is the ability to rotate about your center of rotation while moving in any direction. So I can move this little animation around. It's got 4 Swerve pods on it, each different colors, and the arrows represent which way the pods are driving. So you can see I can move up and left, down and right, and I can even rotate around my center of rotation. But you can also move while you're rotating, so you don't even have to stop and realign to, say, pick up a game piece or get around some defender. So this uses a lot of really complex trigonometry and some things called closed feedback loops, which I'll get into in a minute. But this is, I mean, there's a lot of other reasons you use Swerve too, but this is the main benefit, is that you can rotate about your center of rotation while moving and you have four-wheel drive. So there's other drive bases that are called mecanum drive bases. If you've ever seen forklifts, they have those wheels inside of wheels, and that allows you to move sideways as well. But the way that works is you basically sacrifice motion and energy by sliding. So when another robot pushes on you, you basically just give way to that other robot. But with swerve drive with the four wheels, you can push and have that same amount of motion. So one last thing I want to touch on the swerve is how we control the angle of each pod. So Nick talked about how we've got an encoder and a motor on a belt that controls the direction of that saddle. And that is one of the most crucial parts of how the swerve works, because if any of your pods are pointing the wrong direction, so say you had them pointed all away from each other, you would literally just burn holes in the carpet, which we have done a lot of times, as he also mentioned, and it's not fun. So in this diagram you should see here, this is an example of a closed feedback loop. So closed feedback loops can mean a lot of different things in industry, but for the ones I'm going to be talking about are what are called position closed feedback loops, and that consists of a motor and an encoder. So the encoder tells you at what rotation your saddle is between 0 and 360 degrees, and then the goal, the ultimate objective, is to get the motor to point the saddle at a specific angle, regardless of other factors like friction or other people pushing on your robot. So the center line here, the 0, is the desired position of your saddle, and then this blue wavy line is the current reported position of your encoder. So this would actually be a poorly tuned control loop because it's oscillating, so you would have your saddle moving back and forth, but it illustrates the point well enough. So if you look at the beginning, it rises up and peaks at about 0.17, and then it realizes that it's trying to get to 0, and so it rotates the other direction. Then once it gets to 0, it overshoots and it slowly oscillates to 0. And so if this was properly tuned, you would just see a single arc that comes and it slows down as it approaches 0, and you would be at the desired position. So it seems really complicated and maybe unnecessary, but the reason that we do this is because if you're using a complex assembly with a lot of moving parts and belts and bearings that have unknown properties, such as different amounts of friction or weight on each pod changing the amount of friction, you're going to need a control loop that can dynamically adjust the output of your rotational motor so that you have the correct angle. And so this is what we've done. This is what lots of teams do in FRC. It allows for a very robust ability for your robot to maintain angles of your swerve pods, or even like positions of elevators or anything like that. And so there's a lot more. I could go on and on about the swerve. There's a lot of stuff that goes into it, but I want to cover one more thing in programming that we do is called computer vision. You might have also heard it called vision processing. And that's literally the act of taking a computer or a camera and teaching it to understand the world around us. So we as humans see things and we say, that's an elephant, that's a chair, you know, we identify things and we associate properties with them. But with a computer, it doesn't know how to do that. So what we have to do is we have to train it to recognize certain objects and to either drive towards them or do some action in relation to them. So the first 15 seconds of every match in FRC is autonomous, so we can't touch the controls. We have to pre-program instructions that tell the robot where to go and what to do to attain some sort of objective. So this is, it's kind of hard to see, but there's two pieces of vision tape juxtaposed to each other like this on the image. And this is from 2019. And the goal was to get to this vision target and drop a game piece like a ball or a hatch. So the way we went about doing this is we have a camera on a robot that has an array of infrared LEDs around the lens. And the reason we used infrared, it'll become apparent in a minute, but there's other light sources in the visible light spectrum in the arena. So when you use infrared light, that allows you to negate those as a source of noise. So that way you don't end up tracking lights or tracking people with phones that shine into your camera. So we shine infrared light at this tape, and you can see it makes it look really super bright, like it's emitting a light source. And this tape is made of like material, kind of like safety vests or traffic cones. So it reflects light really well. But then the problem here becomes is now we're seeing both visible light and infrared light, but we only want infrared light so we can filter everything else out. So we put a little lens, a piece of a floppy disk actually, which filters out everything but infrared. And that we put that over the lens, and that gives us this clear, crisp, just the vision tape image, which is really half the battle with vision processing, is eliminating all noise, so you have just what you're trying to look at. So from there, it's fairly straightforward. We just do contour detection, which is just finding all of the shapes and blobs in an image. And you can see those are found with the 2 red rectangles. And then one nuance of 2019 that was part of the tricky part of finding these vision targets is you can see it's composed of 2 pieces of vision tape that are angled like this. But there was, I think, maybe 20 per half the field of these sets of vision tape. So you wanted to find the pieces of tape that were sets rather than if they were pointed away from each other. That means that there's 2 next to each other, and you would just be going towards an empty spot on the field that means nothing. So the way we got around that is we drew line segments coming out from each of the vision targets, and if they intersected one another, then you know that that's a pair, and you treat it as a pair. And you can see that red dot at the top shows that they are treated as a pair. And using this, we can take the center of in between those 2 pieces of tape, and that's a target that we want to track. And so you can see it's robust. If there's 2 target sets on the image, then it treats them as separate pairs, and then you just choose one to drive towards. And so that helped us to create a fairly robust vision algorithm that year to drive towards the targets. And that was a couple of years in the making. We did some in 2018 that got implemented to a limited extent, and then 2019 we took it up a notch with this. So that's a couple of things that go into programming robots and cameras at M.A.R.S.
I just have to say, it looks like a Jedi is fighting a Sith Lord.
I played with this, like when I had it working, I was just like playing with it so much.
Yeah. It looks like 2 lightsabers in a dark room.
Oh yeah.
That's awesome. That's crazy. I had no idea so much went into the autonomous mode in your guys' competition. That's nuts. Awesome. That is pretty sweet. Thanks for sharing that.
Well, I'd like to ask a question of the 3 students. How did you guys learn this stuff?
Painfully.
Painfully. I mean, there might be some students out there saying, I've never seen any of this stuff before. I wouldn't know how to do it. Therefore, I don't want to do it. How did you learn how to do it?
Speaking just for me, I'm sure Nick and Matt have their own ideas they'll share in a second, but the way that I mainly learned it is, like I said, I joined in the elementary school. So I've been doing this for a long time. And so the way that I think there's 2 different facets. There's learning things, and then there's like just getting excited about these things. So if you have an objective, like say you want to make a robot that follows a line, which is one of the first things you do in robotics, if you are interested in doing it and you're excited about doing it, there are resources all around you. Like, if you're on a robotics team, you can learn from the mentors or from other students. But even like myself and my personal projects, there's so many resources on the internet that allow you to learn things for free, such as this. So I think half of the challenge of learning these things is learning how to make yourself learn them and saying, this is difficult, but I want to learn this and it's fun and engaging. So I'm going to find the resources and spend the time to learn this skill so that I can do this cool thing.
Passion is an awesome driving factor for sure. A lot of times passion beats out knowledge, 9 times out of 10.
One of the cool things about the robotics program, like Harrison said, it gives you an excuse. It gives you a reason to do something, right? So even though you may not know how to do something specifically, given the challenge and the fact that there are many other people on the team that all work on something, helps to propel you to want to learn something new and then share it with the rest of the team or shared with the other teams at competitions. So it gives you that driving force to want to learn something else, to come up with something new that you can be proud of, both as a skill and as a finished product. And so it's more the avenue that is provided by FIRST Robotics than the actual fact. The fact is something that is almost always up to you yourself to learn. We just provide the ways and the means to do that. So Dave, to answer your question more directly, Mike and I have no clue how half of this stuff works. we just sit there in amazement at what these kids come up with, and you know, we just provide the opportunity for them to do so, and you get a few of them together, and then things start snowballing, and one has an idea, the other one builds off that, and then before you know it, you've got this crazy robot that spins as it drives, and it tracks, and it shoots, and it does all these things, and we're like, oh my gosh, where did all this come from? And Mike and I feel like we're left behind.
Well, that's an interesting point, Mike. So any prospective parents, coaches out there thinking, gosh, I've got to have an electronics degree or a mechanical engineering degree, you just said, no, you don't. You just
Nope.
got to give the students the opportunity to follow their passion.
Yep, supportive, inspirational. Those are the kind of qualities that we look for, and present. That's the other part. You know, you've got to have time. You've got to be willing to give your time, and you put all those things together. And like you said, you provide the venue, you provide the opportunity, and they'll run with it. It's awesome watching.
First is so much more than just like programming a robot too. Like you guys get into kind of like the team management, right? Like marketing your team, and you know, project management, coordinator. Like there's roles for all kinds of people. Maybe they're not programmers, right? There's tons of
Absolutely.
roles.
Yeah, statistician, you know, is one that we've really gone heavy on our scouting. When you're at competitions, you know, the scouting people are the ones who go around and really study the other robotics that are present at the competition, how they behave, how the drive team that operates them behaves, and the idea is, in the end, to win, you've got to put together a team out of, you know, the full field of people that went through all the seeding rounds. So you get an opportunity to preview, you know, abilities, and then you get an opportunity to build what they call the final alliance, which you go through the bracketed rounds, you know, for the win at the end. And so the statistician is a very important spot, and you know, so that just one more aspect, like you said, of being on a team. You don't have to build, you don't have to you know, program. You know, you can study and provide, you know, valuable information, all part of a big team.
Yeah, and anybody interested in learning CAD or learning anything like that, like there's so many free resources now, and even us Fab Lab, because we can't be in person, we've been trying to do workshops and webinars just to kind of get that STEM technology and software and resources out there, just so that everybody knows, like, yeah, this is easy. We're doing this stuff via Zoom, people. Like, you can jump in. It can be, whether it be Tinkercad to start, right? Like I've seen some amazing things done in Tinkercad the last couple weeks. Like, I'm like, what? You know, to more adult CAD, like, you know, Onshape or SolidWorks and stuff like that. Like, the skills translate. It's getting that creative mind, giving you it an outlet. Yeah.
What's cool about the program is that we get a lot of these resources from companies that you know, that is top of the line software and hardware, and these kids learn to use all that stuff on the fly, and before you know it, when they graduate high school and then go on to university or college and move on to their first career, all of a sudden they have all these experiences with this state-of-the-art technology that they'll very likely be able to use in their career.
Huge head start.
They get it while they're doing it, while they're in high school.
Yeah, not to mention the recognition from the hiring companies. You know, internships are huge inroads that kids get. We've got a local company, Smart Vision Lights, that has offered at least 4 of our students now internships they've been through. And I don't know, 3 of the guys that have been part of that internship program are here with us tonight. You just heard from them. So, those are the kind of kids that are out already working in industry, getting experience before they're even at college.
I'll tell you what I didn't do before I was out of high school. I was playing Magic the Gathering. I didn't have a revision to a swerve drive, and I was like the engineering nerd. So it's amazing.
So Mike's, if I'm a student and I want to join a robotics club, how do I find out if there's one in my area to join? And if I'm a parent who wants to start a robotics club in my area, who do I reach out to start that process?
So there's a website, firstinspires.org. Maybe we can put that in the comments, Chris. It's firstinspires.org. And through that, you can search your area to see if a team exists, and you can reach out to them. Or if no team exists, you can reach out to any team, and I will guarantee that all teams will provide you with information on how to get started. They'll be helpful to get you started. We ourselves have helped several teams get started in the area. Orchard View now has a team, Oak Ridge has a team, Ravenna has a team, and we've helped all those teams out, except for Ravenna. They're being helped out by Fruitport. But many of the teams in the area here are helping to start other teams. So if there's anybody out there, if you have any questions, please go to firstinspires.org. Reach out to other teams. If you're in our area and you want to reach out and find out whether somebody, reach out to us, muskegonrobotics.com. You can get in touch with M.A.R.S through that avenue, and then we can point you in the right direction. But there are plenty of resources out there, and it's very easy to get started, and it doesn't cost anything to come in and check it out. If you like it, great, we'd love to have you, as with any other team. If you don't like it, just say thank you, that's not for me, and move on. But it's something I think everyone should at least make an effort to check out at least once.
You don't know until you try.
Exactly. And so many times somebody comes to us with one thing that they want to do, like Mike was saying, the statistician. We had one kid come to us and he wanted to program, just could never quite get into it until he realized, oh my gosh, here's this statistics. He's now at Tech studying statistics because he loves it so much. He had no idea, and this was his wake-up call, where he was able to dabble with it and try it, and he found his passion.
I have to say it was pretty amazing, like the 2 kickoffs that we've done down at Muskegon Community College Stewart Tech Center and Lakeshore Fab Lab. Just like afterwards, it was like, all right, break. Some teams went back and worked on their stuff, but like you guys, and maybe it was just you guys, M.A.R.S, but you guys were like, all right, we're going to do mentor sessions for, these newbie teams. Like that's cool. It's not just like super secretive, it's very collaborative.
Yeah.
It's awesome.
There's a question here from Thomas about the top speed of our builds.
Maybe he means like time frame in which you guys have to build in.
I don't know. Maybe he can.
It's pretty quick. What is your guys'
Our feet per second? Nick and Matt will tell you the feet per second. I bet
can it do the Kessel run in 12 parsecs?
Oh, absolutely.
Easily.
With or without cloaking.
Go ahead, Nick.
All right, so yeah, this gear configuration is geared for 17 feet per second. That's just the theoretical, or we figured it goes 15 feet per second because we can't exactly calculate all the friction and motor output or everything like that. So without any friction, 17 feet per second, but we figure about 15.
In miles per hour, that's fast. At least for a 50-foot field.
Very.
It's faster than you're opposing robots when you're going at them.
I want to see battle bots with sword drives.
I was right behind you at that as battle bots.
I actually just found
that's great until $10,000 goes down the drain, and then you just cry.
That's where sponsorship comes in.
I just found Nick's YouTube channel, and I'm at a spot where the swerve drive's acting, so I'll play it. We'll see if this works. If you guys can actually.
That's Harrison's response to winning.
Yeah.
Ooh, our elevator.
It's like you guys have
we don't
fun.
do that. That's not safe. Don't play that.
Wearing a helmet, it's okay.
Yeah.
So we didn't talk about pneumatics, but that was a great example of a frame back or so where, we don't always use electronics, for actuation or electricity for actuation, indirectly, I suppose. But we use pneumatics as well on these systems.
So right there, that was Team 404, the red.
Oh,
right?
yeah, look at the swerve.
Swerve
That's
drive
our
right there.
signature move right there.
Yeah.
Swerving around the competition.
Oh.
So, can you have a swerve inside a swerve? Like, make a swerve that
We have
swerves?
talked.
This
Mostly
is like-
Nick talking and me saying, no, go back to college.
This is like swerve inception. Yeah, that's cool.
We do want to try and miniaturize the swerve and use it on the 18 by 18 by 18 size robot that we do, in the first tech challenge.
I want a personal vehicle where I can just drive around like.
Well,
this.
you saw the kids riding this thing. We'll make you a chair.
Pretty sure NASA made one of those. It was a car and it had swerve and it was beautiful.
Yeah.
It wasn't like the Honda Swerve. We can't get that.
Look at there we are playing crippled.
Oh yeah, what was up with that?
Well, it happens, right? Stuff breaks.
Yeah.
Yeah, our intake fell off and was hanging on by 2 strings. So we just brought it up and down on top of the ball with the wheels going in. And so the wires were still attached and stuff, but we were kind of just having it go up and down.
It's like playing with a broken arm.
Sure, that's what it looked like. It was like hanging down there.
Yeah, it was inspired by my claw machine.
Awesome. You guys are keeping busy, right, in this quarantine life? Like, I know, Nick, you're out of school, and Harrison, you still got more school probably going on right now.
Yeah, I got another week or so.
We've not met as a full team in quite some time,
Sure.
but I think as things start to slowly come back, we'll bring small teams back together and then continue working towards next year. We don't know what changes, if any, we have to make, or if we can even reuse this year's robot or have to build a new one. But our goal for the summer is to bring up some of the other students who are newer on the team, or who are going to join us, like Micah here, and bring up their skills and introduce them to some of the things that you've seen some of these kids who were just on tonight have learned. Now this is not, they've spoken at very high levels. This is not something that happened overnight. As you've heard, they've been with this for many years, and like Mike said earlier, this is something that happens through dedication, and you have to be there. You have to put in the time. But let me tell you, when you put in the time, you sure reap the rewards, because there's a lot of interest out there from these companies looking for people that can do this kind of stuff.
Wasn't it one of the the Whitehall team or Montague? One of their students went and did an internship at NASA.
Oh yeah, there's all kinds of internships at NASA. Stryker, a big medical company down in Kalamazoo, regularly brings some of the hand-selected students from the Michigan First community to their campus to show them around and literally recruit them, almost like you have your football or sports recruiters go to games. These guys come to the competitions and they say, hey, we want you, we want you. They pick these kids at an early age to try and get their claws into them, and they're not the only ones that do that.
Yeah, indentured servitude isn't all bad.
Right? I'm sure Stryker pays pretty good.
Yeah.
Yep. Here's your job. We'll put you through college. We'll teach you everything we know. We'll steer you, in a selfish capacity. But, meanwhile, the kids they get the reward.
Yeah.
That's awesome. Does anybody else have any closing remarks?
Well, a lot like what we do, the Lakeshore Fab Lab does, and that's just provides the opportunity, for everybody to do it. So you don't have to be on a robotics team to be a cool, budding maker, or someone who's learning, new skills. So
Yeah, Mike's
of course
taking my job from me, plugging myself.
sorry, we'd
Hey.
No,
love
you're
to
good.
have you on our team, but there's a whole world of this kind of stuff happening out there, and until you bring people together at a common place, these people often don't even know each other exist.
Yeah, it's you guys have known firsthand from just how close knit your teams become. Like in the past 2 years, we're infancy compared to you guys, and like we can see it. Like
Well, what you guys are doing is great, and we love having the partnership with you that we do, both for the kickoffs and otherwise. And we hope that other teams in the area will follow and continue to visit the Fab Lab and help you guys spread what you do, because like Mike says, you got to get people there and you got to get people to see it.
seeing is believing. It's one thing to describe things to people all the time. Like, yeah, just come to the Fab Lab, 3D print some stuff, CNC some stuff. That'll never get them there, but when they experience what you can actually do, that's what draws people in. I mean, that's kind of what pulled Holly in. hey,
Yeah.
can I teach my kids here?
I'm
Sure.
like, listen.
Guess what?
Yeah, I was like, we can do this here. We can just walk in. I was like, all right, I'm never leaving.
Right.
That's what we got to get. So, yeah, we would love the opportunity to do the same thing and reach out to parents or teachers or anybody and really support them at the Fab Lab and connect them to the other robotics teams and see, if people are going to start building their own teams, like with the VEX robotics program, they can get that support and that connection there. So, yeah, we love them. We love robotics.
Yeah.
Fun to make stuff move.
Oh yeah. At some point, you guys got to bring your like t-shirt gun robot by. I need to see that thing.
Yeah.
Sure.
The Gatling gun.
Yeah.
Mhm.
We have fun.
Sweet. All right. Well, that'll do it, guys. Thanks for tuning in. If you're watching this post-production, thank you for watching. And there'll be links in the YouTube video below, so you can find anything that we've shared and talked about today, such as M.A.R.S, the Lakeshore Fab Lab, firstinspirators.org, even the cool M.A.R.S promo video. I'll put all those links in the description. So awesome. Thanks, everybody.